In this question, we are asked what mass of sodium carbonate is needed to produce 500 milliliters of a solution that is 0.2 molar in Na+. We are given a hint that we will need to determine the molecular formula of the solid and how many moles of Na+ is produced when 1 mole of the solid dissolves. Well, first let's think about what the compound is. We have Na plus 1, because it's in group 1, and carbonate, which has a 2- charge. So the actual compound, when we think about crossing the charges, will be 2 sodiums to 1 carbonate. So when this sodium carbonate dissolves, we should get Na plus in solution and carbonate in solution. And to balance it, we need a 2 in front of the Na+. 1 carbonate is just fine. Another formula to know that's very helpful is that volume times concentration will give 1 moles. So notice that our volume is 0.500, and I'm going to put this in units of liters. This is so that when I multiply it by the concentration of 0.200 mole per liter, I have now made it so that the liters will cancel out. When I multiply this, I find out that I need 0.100 moles of Na+. Now I just need to figure out the grams, but I need to be careful about the stoichiometry and the fact that there are 2 moles of Na+ for every 1 mole of sodium carbonate. So I will start out with 0.100 moles of Na+, and I will recognize that there are 2 moles of Na+ for every 1 mole of sodium carbonate. Then I can multiply by the molar mass of sodium carbonate, which is 105.99 grams of sodium carbonate per 1 mole of sodium carbonate. Notice how my units cancel out. I have gotten rid of moles of Na+, I have gotten rid of moles of sodium carbonate. I am left with what I've been asked for, which is grams of sodium carbonate. And that answer turns out to be 5.30 grams of sodium carbonate.